In this video, you will see equation 1 done 2 different ways. Do a split screen with your worksheet.
All right, students, we are talking here about balancing chemical equations. That's where we make sure that all of the atoms that are on the reactant side show up somewhere on the product side. It needs to be equal numbers of each element on both sides. So in this example, we're talking about sodium plus molecular chlorine, which is Cl2, becoming sodium chloride, which is salt. And in any balancing chemical equations sort of scenario, you always wanted to start off by keeping track of how many of each element you have on both sides. Now, in this approach, I'm actually going to use kind of a visual approach, and what I'm going to do is I'm just going to create a dividing line here. I'm going to create a bubble for sodium. I'm going to create a bubble for chlorine. And we have the same elements on the product side too, so I'll create a bubble for sodium and a bubble for chlorine. Now, on the reactant side, I'm going to keep track of my sodium atoms as orange, and I see that I only have one on the reactant side because there's no coefficient, no subscript. On the product side, I see that I have one sodium as well. All right, now on to chlorine. Chlorine here, I see that I have two chlorines because the subscript 2 tells me that there are two chlorines in every molecule there. So I've got 2. On the product side, this chlorine has no subscript and no coefficient here, so it's just going to be 1. All right, and so now I take stock of, am I balanced, right? Because you can see from sodium on the reactant side, sodium on the product side, we are totally balanced. Check. But when you look at chlorine, we've got 2 here and only 1 here. So that is a no-go. We are not balanced yet. And that means that we need to start adding coefficients. Now, as much as I'd like to change the subscript just to make it easy and go down to 1 chlorine, I cannot, because in chemical equations, you cannot change the subscripts. Don't change the subscripts. Don't change the subscripts. Think of that song. Let it get stuck in your head. It's fine. All right, so what I can change is the coefficients. And so I'll start by figuring out which side needs more. Well, the reactant side has more chlorine, product side has less. So let's try giving the product side a coefficient of 2. Now that doesn't just affect the chlorine, it's going to also affect the sodium because they are part of one compound together. So I'm going to add a sodium atom. I probably need a bigger one. Boom. And then I need to add a chlorine atom as well. Boom. All right, so let's recheck how we're looking as far as our balancing. Looks like our sodiums are no longer balanced. Oops. But our chlorines are balanced. Yay. Well, in balancing chemical equations, it's always this way. You go back and forth until you get everything balanced. So now we got to figure out how do we get the sodiums to be balanced. Well, I have 2 on this side, so I need a little bit more on the reactant side. I'll add a nice 2, very bold, wow, 2 there. So now I need to update my picture with the bubbles. So I know that I have 2 sodiums here on the reactant side, 2 on the product side. Oh my goodness. Is this the, boy, where did that come from? Okay. This is the moment. Sodium, sodium. There's 2 of each on both sides. And 2 chlorines on both sides. So we're finally balanced. Yay. All right, so that is another approach that you can take if you like the visuals of it. You'll notice that this here is the actual final answer of what the balanced chemical equation looks like. The bubbles and everything is just a drawing, just a way to keep track of things so that I make sure that I've got it all right. Hope this helps.
Hi chemists! I'm going to show you the underline and count method. First step is to underline and count the atoms that we have here. So I see capital Na with no subscript, that's 1. Capital Cl for chlorine with a subscript 2, that's 2. And then on the other side of the arrow, 1 Na and 1 Cl. No subscript means 1. So now I go back to the left side and I'm looking here and I see 1 Na, and then I jump over to the other side and I see 1 Na. So that's good. Now I look at my Cl's. I look here and I see 2 Cl, and I jump over to the other side of the arrow, only 1 Cl. So that's not good. Now the one that is lower is the one that I'm going to change. So I'm going to add a coefficient in front of this molecule over here. I can't just change the Cl because it's attached to the Na. It's a package. It's a molecule. So that changes both of these. So I'm going to show below that now there are 2 Na and 2 Cl. And that means I'm going to go back and double check. Now I look, my Cl's are good, but I go back and I see, oh yeah, now this Na is still 1, but this Na became 2. So I go back to the one that's less, the 1, and put a 2 in front. Then I multiply to double check. Now everything is equal. 2 Na, 2 Na, 2 Cl, 2 Cl. All of this below here is extra, just showing my work. It's those coefficients that I need that make it balanced.